And it is my honor and pleasure to present the next presentation, which is, to present the author of the next presentation, Professor Fernand Marquis, on advanced materials successes and challenges in the era of sustainable development. Professor Fernand, please on stage. Professor Marquis has been always a material science and sustainable framework of FLOGEN sustainable framework. So the presentation will cover what has been successes until now in advanced materials in the viewpoint of sustainable development, especially FLOGEN sustainability framework, and what are the challenges we are supposed to tackle and achieve successes.
Thank you very much. Thank you. Greetings, everyone. Thank you for coming. Advanced materials have always played a most important and critical role through history and through the development of all civilizations. And that's why some of the eras were called after them. The Stone Age, the Bronze Age, the Iron Age, the Silicon Age, and I will not be surprised that we are in the beginning of an era that can be considered the nanomaterials age. So, I want to give you an outline. What is sustainable development? Challenges in sustainable development. I will cover briefly all the domains of sustainable development, but for reasons that we will see during the presentation, I would focus on the transportation domain. And I will share with you, what has been happening in this domain, that evolution from more conventional materials to nanomaterials, and I share with you some of the major successes, in advanced materials, and then I would cover some of the applications and properties. So there are three fundamental resources. You can also think of them as systems of systems in sustainable development. The planet, natural resources, fresh water, clean atmosphere, fertile land, productive oceans, minerals, fossil energy, biodiversity. Then prosperity, or the manufacturing, resource. And this is a complicated system, and how we can measure them, let us say, by the gross domestic product, GDP or G, And then you have the people, the human resources, Education, knowledge, scientists, engineers, medical doctors, So in order for us to achieve sustainable development, we have to develop and expand cumulatively all these three resources without any sacrifice on any of them. Now, these resources are there, but they are not independent. They are interconnected, and they must be activated in order for us to achieve sustainable development. And this brings us to the trademark, of SIPS, So we have here these three pillars, So science and technology is the communication of the prosperity with the planet, okay? Governance and management is the communication of the prosperity with the people, and education and civil society is the communication of the people with the planet. So it's basically a question of educating people in stewardship. So if we come back to these resources, you may wonder, which of these resources is the most important? You may think it is the planet, but it isn't, okay? It is the human resources. And if you look in the last millennia, or half a millennia, all the empires, the Portuguese Empire, the Spanish Empire, the British Empire, the American Empire, they all rise to the peak of prestige and power, okay? And then start decreasing, and they were catapulted by the knowledge, by the scientists, by the engineers. And today we can forecast the decline of any civilization, any country, by just measuring the number of scientists and engineers and the quality of those scientists and engineers. So this puts us forward, and we have these resources, and we have challenges in achieving sustainable development. And the nature of these challenges and the magnitude of this challenge depends with how many people are we sharing these resources, and what is the type of activity, what is the lifestyle of these people. So if you look at the evolution of the population in the globe, we experience that exponential growth, okay, which bring us additional challenges. So we may be at the initiation of a slow in this growth, but that does not change the fundamental challenges that we are facing. Okay. So that pursuit of prosperity, catapulted by the Industrial Revolution that started in the United Kingdom around 1760, brought with it a considerable amount of emissions, and a considerable amount, so this gives you the amount of emissions and the rise in the content in CO2. But although we talk most frequently about CO2, there are many other critical emissions with unit of effect of higher magnitude than CO2. And these emissions are continuing to expand, okay, bringing us some challenges. So in US, in 2016, the major domains in sustainable development, as far as emissions are concerned, is the transportation, as you can see, and that's one of the reasons why I'm focusing now on transportation, but I will make some comments on the other, domains of sustainable development. So if you look at the ownership in 2004, you see that our large ownership is right here in the US and the Western world, which are countries that are not very populated, when the most populated countries are right here, okay? But things have been changed, and the situation now here is identical of what we expect on top. So the projections for the demand of the transportation energy would continue to rise very fast, okay? And therefore, this brings us additional challenges. And if you look at the global transportation energy, as you can see in here, is primarily fossil fuels. Electricity and renewables are still coming up with a very small contribution. And in the United States, if you look at the transportation theater, the major users are light-duty vehicles, trucks, and air transportation. So if you look in general at the situation with emissions, and if you want to try to quantify it, these emissions, total emissions F, are equal to the population, the gross domestic product per capita. This is the energy intensity, energy used, gross domestic product, and the emissions intensity for a specific form of energy. So if you want to decrease F, and the population is continuing increasing at a very fast rate, okay, and we want to increase the domestic, gross domestic product because it is an index of prosperity, there is only two ways to go. Is decreasing the energy intensity, that means we have to use less energy, or change the type of energy that we are going to use. And that's where, okay, advanced materials have been making and continue to make outstanding contributions. So the drivers to bring advanced materials in the transportation mode are less fuel through reduction of the vehicle weight, less pollution, better drivability, increased safety and performance, the need to develop multifunctional materials and integrate in the design materials and functionality, deployment of recyclable and environmental friendly materials, and this, of course, is all designed to decrease, okay, both E over G and F over E. We have considerable challenges as we try to design, try to select, try to develop these materials. And there are primarily four types of challenges. Future-oriented. We have a lot of instability in the political theater. We have considerable volatility, okay, in the prices of the fuel. And we don't know for sure what is the form of energy that we'll be using, okay, in 10, 20 years. And this brings us additional energies. The need to develop multifunctional materials and integrate these materials with functions is another challenge. And as we introduce these new materials, the original cost is very high, and we need to sort of, recuperate that cost, but for that, we need to have assurance that whatever energy we are planning for is going to be, in fact, the energy that we'll be using. And this is challenging. So, as you look at materials, we are plotting here specific strength and specific toughness. So, strength divided by density, toughness divided by density. And what we are seeing in here, okay, plastics, okay. Okay, I don't think the pointer is working in there. Okay.
It was working.
Okay, so you can see, okay, the plastics, the metals, the metal matrix composites, the polymer matrix composites, then the carbon fiber composites, advanced carbon fiber composites, and then the carbon nanotube composites, now the graphene composites, and other nanomaterial composites. But these new composites, as we are going to see, they are not like the conventional composites. They are fully integrated composites because now this reinforcement, okay, is such that we can introduce it in the matrix, not as a separate, reinforcement. And this allows us considerable flexibility. So, the journey took us from conventional steels, high-strength steels, ultra-high-strength steels, metallic lightweight alloys, the aluminum alloys that were developed specific for the Boeing 777, okay, magnesium, titanium, the plastics, and the fully integrated composites now using, nanomaterials. So if you look at the theater in 2005, an automobile just only has a cargo of 18%, okay, and an aircraft 10%, okay. This is a really very high energy intensity. So what we need is to change this panorama, and there are some outstanding examples of how this was achieved. So here you have the Boeing 787 of Dreamline, and this is an amazing success. It was a venture between Toray in Japan that developed and manufactured the advanced carbon fibers specific for this aircraft, and then Boeing that designed and built this plane, okay? And you can see that you have 80%, okay, of composites in the we are not going to have time to go all over the details how these materials have been incorporated and why they are making such a big difference. But basically, they are allowing us to increase the cargo, the number of the passengers, increase the range, okay, and therefore decrease energy intensity. Another example that I want to share, before we go forward, I want to share with you basically, some pictures of the developments of these advanced carbon fibers that were developed specifically for this plane, but now are used everywhere in all the domains of sustainable development. Another plane, which is an amazing material success, is the Airbus A380, when most of the conventional materials have been replaced, okay, with advanced composites and hybrid materials. Again, we don't have time to go through all the details of this incorporation, but what we are seeing in here is that the cargo has been extended, the range has been extended, and the energy intensity has decreased considerably. And if you look at the panorama of evolution of the energy intensity in jet engines, you see that that panorama is continuing showing us tremendous decrease of the energy intensity. So we are quite out of the range of that slide. And these materials now are employed everywhere in transportation. 60% lighter compared with steel, 30% lighter compared with aluminum. Improved fuel efficiency, improved body balance, drivability. Some examples, where they have been used. Okay. Transmission shafts, 50% lighter, less vibration, less noise, increased safety, and some of the concrete examples that we have active. And when you look at the cost, okay, of these materials, we see that the primary cost comes from the cost of the material itself, okay? And this allows us to move forward to the next level and use not advanced carbon fibers, but now, okay, nanomaterials such as carbon nanotubes and graphene. And if you see the evolution of the price since the discovery in 1991 until now, the price continues to decrease considerably, and the quality of the material is increased tremendously. The same panorama is observed with graphene. That means now we can bring these materials as the new materials, and this is a schematic, presentation of where we can, employ them. We are not going to have time to go through all of these, but I want to share with you, okay, how these materials are incorporated. So this is a colloidal suspension of carbon nanotubes in Diraken. And we now have the reinforcement in the matrix, and we can just go to a conventional fiberglass mat and infiltrate that in a three-dimensional configuration. That means that these carbon nanotubes are now going to rise considerably the resistance to fatigue crack initiation and the resistance to fatigue crack propagation. This is, in fact, a great achievement. And this allows us to even bring these materials to larger vehicles, okay, where only specific critical locations of the design need to be further reinforced. This is some of our work done with in the beginning of the applications of the carbon nanotubes. We have Professor Rao designing some materials for us, and this is what happens with the thermal conductivity of these matrices as we add the carbon nanotubes. And if you are going to test these materials, if you are running an engine from low revolutions up to the maximum of revolutions, we are observing that the temperature of this engine is always much lower when we use nano lubricants. And this means that we are dissipating more heat, but we may be generating, less heat due to higher lubricity of these systems. And this is another successful story of the incorporation of nanomaterials, okay, in batteries when you can increase the energy density and decrease the recharging time. okay, and make the material safer. Other examples for supercapacitors performance, when we can increase the capacitance and the energy density considerable. And this is now being used to develop new forms of the energy and apply these materials not only in transportation, but okay, in energy generation, okay, in storage, okay, in the construction field, green buildings. If you look at the panorama with green buildings, you can see that you can save considerable amount of energy and achieve a higher quality of the living standards on those green buildings. So we could continue, but the time is limited, and I want to move into the conclusions. So the challenge of expanding simultaneously the resources, the fundamental resources of sustainable development have been achieved. We have been making amazing contributions in decreasing the energy intensity and the fuel, the emissions density, and we are having now additional opportunities to incorporate those materials, not only in transportation, but also in other domains or sectors of sustainable development. And I want to pause at this stage, and thank you very much, for being here.
Thank you, Fernand, for an excellent overview of materials and how important they are, applicable everywhere in all fields of science. So you concentrate only in some parts, but
do we have time for questions?
well, only one question, but very short, if they have. Normally, you don't do questions during plenary, but it's okay.
Okay.
There's no question anyway. Okay. So thank you very much.
Thank you.
I really appreciate it.